All right, welcome back. So I think I skipped my video yesterday, or at least the after work video. Yeah, I'll just be honest. I don't have coronavirus, but I think just not doing the regular activities I would do because of the lockdown and all that, and then in Texas it's just getting worse, and then not having my regular schedule is really kind of not working for me. I'm having a lot of trouble focusing, and recently my diet has gotten kind of out of control, and I received some grocery items that I didn't order, some of which just wasn't very healthy food, and unfortunately I didn't have the will to just throw them away. So the goal is to learn, of course. So I have definitely learned that the next time I get an unexpected order of food, and I really like watching basketball. I don't play much myself, even though I'm like 6'2", and watching the players in the bubble, they pulled out the free food they got, and they said, "Nope, nope, nope. I need to learn how to do that myself." Because even though I'm not an athlete, I consider this kind of an athletic endeavor in some ways, a mental athlete, if you will. Okay, so where I left off last, we were looking at BGP attributes, and we were looking at BGP path selection. So BGP attributes are a subcategory of that because they're used to make a path selection. So my goal was to just do all the way front to back. One of the labs I found through the treasure trove script that I made. So here it is right there. So came pretty close to getting that to work. Yep, so last time I applied all the configuration, then I wired everything up, and I put it all, and I rearranged the topology so it makes more sense. So yeah, we won't need to be going through any of this. This is just the step-by-step. Juniper usually gives you a way to quickly paste the lab, as well as a detailed step-by-step explanation. Some more quality than others, but okay, so this video I will be doing the verification steps. This series will be more similar to what I've been doing with version 960. Yeah, but I am definitely not feeling good, and I don't have coronavirus, but I think it's just because my diet hasn't been good. I've been eating junk food, and I'm 35, so I can't get away with that. And then I haven't been exercising. I haven't been seeing friends face to face. It's just I'm heading for a health disaster. So good news for me is my kitchen pantry is stocked with health food right now. I don't have any junk food left. Not even food that's on the fence. Everything there is good. And I can go swimming. I'll probably go swimming today. I can see friends too, because I can go 6 feet apart to a park and stuff, and I know some friends who are doing that just about every week. So yeah, I can definitely get back on the bandwagon, if you will, and I think that will help me focus on this test, because right now it's just I got to do something because my focus is just shot. Okay, so it looks like all of the neighborships are up. So it looks like this is just what they want. So we're going to need to verify. So for verification, we're going to confirm that the configuration is working properly. First, we're going to verify that the BGP neighbors have the ability to send and receive multiple paths. Then we're going to verify that router R1 is advertising multiple paths. Then we're going to verify that router 4 is receiving and advertising multiple paths. We're going to verify that router 8 is receiving multiple paths. So for router 1, we only need to worry about whether or not it's advertising multiple paths. For router 8, we're only going to need to worry about whether or not it is receiving multiple paths. But for router 4, we need to check that it is both receiving and advertising multiple paths. So let's look at the topology and kind of see if we can get a sense for why there's that discrepancy. Okay, so for 4 we want to be sending and receiving. So 8 only receiving and 1 only advertising. Okay, so I bet you it's the same for all of these. These are sending and receiving, and these are only receiving, and then this is, so I'm not sure what router 5 is. It looks like it's in a special role, but let's just keep on going, verifying that the BGP peers have the ability to send and receive multiple paths. Purpose, make sure that one or both of the following strings appear in the output of the show BGP neighbor command. NLRIs for which peer can receive multiple paths. INET unicast, NLRIs for which peer can send multiple paths. INET unicast. Okay, so here we're going to have the term receive multiple paths, and here we're going to have the term send multiple paths. So on router 1, advertising, so we're going to need a value for here. We won't necessarily need one for here. Router 4 will need a value for both of these, and router 8 will just need a value here. So let's start with router 1. Let's kind of ignore what's down there and do it ourselves. So we'll do show BGP neighbor, pipe match, send multiple paths. Okay, so we didn't get anything back. Let's make sure I spelled it right. M-U-L-T-I-P-L-E. M-U-L-T-I-P-L-E. For some reason that looks, you know, that I wonder if there's a psychological term for that experience. I'm sure everyone has had, where you look at a word and you think, that word looks misspelled to me. You think there's an issue with that word. I've never seen it appear so unusual, even though you're very familiar with that word. It's a standard word of your vocabulary and you know how to spell it, but for some reason it just looks unusual to you. I'm definitely experiencing that right now with the term multiple, M-U-L-T-I-P-L-E. Okay, but we've got no. Here we go. So we don't have anything for. Oh, so this is interesting. So, so yeah, so it's gonna be like backwards because we're talking about the neighbor. So it's gonna be really confusing because, so we need to verify that router 1 is advertising multiple paths. So what are we gonna do? We're gonna do show pipe, or show BGP neighbor pipe match, and we'll do multiple paths. Oops. Oh, now I actually did spell it wrong. Maybe this is what I was expecting it to look like. Okay, so we did get a match here. It's NLRIs for which peer can receive multiple paths. So we're talking about our peer. So router 1 is, sure enough, advertising to a peer. And the way we're going to be told that is because we know that the peer can receive a path. Because of that, we know that router 1 is advertising a path. And if we want to see which path specifically router 1 is advertising, we can do show route protocol or show route advertising protocol BGP. But of course, we've got to specify a neighbor if we do that. So let's do a show BGP summary. And let's just go and specify each neighbor. Okay, so it looks like we're advertising multiple. Oh yeah, something, I'm not done with my personal health rants because like seriously just like standing up and talking is like, it's like winding me. I doubt I have coronavirus, but at the same time I haven't gotten tested. And I have like, you know, I walk out the back a bunch and I pass people like this, and I don't wear a mask when I just do that. But yeah, I don't have any of the symptoms of coronavirus unless being winded is a symptom. But I think that's more a symptom of no longer exercising and consuming improper foods. Still, it's kind of scary. All right. So, yep, so we did verify that the router 1 is advertising. And the way we verified that was kind of strange. It was because its neighbor can receive. That's how we know that router 1 can advertise, because its neighbor can receive. And the good news is on the test, I'll have secure TRT, so I can do a control F for multiple paths. It'll be a lot more easy to work with than this is. But let's take a look at the full output. Okay, and then let's try to find where that shows up. So it's right here, just above the table. NLRIs for which peer can receive multiple paths. And then remember, it's peer can. So this router, which is not the peer, can advertise because we know that its peer can receive. All right, so now let's check router 4, and I'm trying not to look at the answer there, so we'll just try to figure out ourselves if it can send and receive. Yeah, I'm like all winded and feels so bad. Okay, so we're gonna need to, yep, we'll just look at all the neighbors for now. Looks like it's only got 2 neighbors. So we know it's gonna show up right above the table. Here's the table. So yep, it can send, so we know that it can receive. And then from its other neighbor, the peer can receive, so we know that it can send. So this one can both send and receive. It will receive from neighbor 10.0.0.10, and we know that because 10.0.0.10 can send, so we know that R4 can receive, since it's a neighbor of the peer that is sending. And then the peer 10.0.0.80, we know can send. Oops. Yeah, we know that peer can receive. This language kind of makes more sense in the context of talking about this peer. So this peer can receive, so we know that R4 can send to that peer. All right, so let's pull up the answer key. And it looks like they're just interested in router 80, or the peering relationship to 80. Yep, but it matches. That peer can receive, so we know that this can send. All right, so let's look at router 8. And now this is talking about router 8. So router 8 can receive. Let's see. So it will say that this can send. So let's verify that. Oops, and we've got a problem here, and that's that we don't have a neighborship to 10.10.80. Oh, okay, yeah, this is what I was expecting actually. So my eyes just skipped through, but yeah, I was expecting them to look at both neighborships the way we did. So yep, they got the same results as we did by looking at both neighborships. So now let's look at router 8. Okay, so now we can see, yep, router 4 can send. And router 8 can receive. Okay, so now let's make sure that multiple paths to the 198.1.1.1/32 destination and multiple paths to the 199.1.1.1/32 destination are advertised to router 4. Show route advertising protocol is what we're going to use, and that's what I used, of course. So let's just go back to where I ran it and see what it's like, because I just think that's interesting because I ran it without knowing what I was looking for. So I just want to go back and kind of look at what I saw. Okay, so they focused on the 1.2.40. Yep, and it looks like for the most part I've got similar output. I'm just missing this 200. But it could have been because I didn't print out the whole thing. So I'm going to do that. Make sure the whole thing prints out. Oh, and it did. And I'm going to take a pause here just for a few minutes. I'll be right back. Okay, I'm back. Sorry for that. If anyone's curious, yes, I did have to do a bit with my health complaints just now, but I am definitely feeling good enough to continue on with the video. So let's, oops, so it looks like it's missing this route. Let's see where this was meant to be configured. So I'll put a bookmark here and then search for this route. Okay, so we got 4 matches. Let's take a look at the matches. Oops, so it looks like the matches are only in the verification steps. I don't see any matches in configuration steps. So I'm not sure why they're expecting to see a route they did not configure. Yeah, so that's definitely something that's very odd to me. Yeah, it's just not showing up anywhere in the configuration steps. So I really have no answer to the question of why they want that route showing up if they don't call for it being configured. And it's a /30 as well, so it's not like I'm just, it's not like the route they called to be configured was like 200.1.2 or 200.2.2. It would have to be a different subnet mask than a /30 for that to be the case. 200.1.1 is going to be a match. They'll have to configure those first 3 octets to be those exact values. So yeah, I'm not sure where that's coming from. I do know where the next hop is, but everything else looks good. We can see we do have multiple next hops. In this case, we've even got 3 next hops. So when you see one prefix and more than one hop, it means that multiple paths are advertised to router 4. So yep, we've got one prefix and we've got more than one hop for multiple routes. It's interesting that this mysterious route here is not meant to be, does not have multiple paths. So I think it doesn't matter to have on there anyway, because clearly we're learning about multiple paths. So if there's a missing route that doesn't even have multiple paths, it's outside of the, it's not interesting anyway. Okay, verifying that router 4 is receiving and advertising multiple paths. Purpose: make sure that multiple paths to the 199.1.1.1/32 destination are received from router 1 and advertised to router 8. Make sure that multiple paths from the 198.1.1.1/32 destination are received from router R1, but only one path to this destination is advertised to router R8. Okay, so let's verify that. We won't need router 1 anymore. So we're going to do a show route, receive protocol, BGP. Okay, so yep, we've got everything looking pretty good. We're missing this route. So make sure that multiple paths to this one are received from router 1, but only one path to this destination is advertised to router 8. Okay, so we'll need to check that next. Oh, so okay, but the advertising to router 8 is going to happen on router 4. I was thinking that the advertising to router 8 was going to happen on router 8, but of course that wouldn't work too well. So let's check the advertising to router 8. Previously, we had checked what was received from the upstream router, router 1. And we can see we received a path that has 2 next hops. So let's take a look at these routes. Okay, so let's take a look at the next command here, show route. Now we're going to look at routes advertised to router 8. So I can't imagine somebody taking this exam without having been introduced to these show route advertising protocol and show route receive protocol commands. It would just be impossible. I wonder if there's more commands like that that I don't know, that it would basically be impossible to pass the test not knowing. But here we can see it works exactly as they expected it to. We've only got one path being advertised down to router 8. I don't understand why that's the case, but here we've got it right up on the meaning. The show route receive protocol command shows that router R4 receives 2 paths to the 198.1.1.1/32 destination and 3 paths to the 199.1.1.1/32 destination. The show route advertising protocol command shows that router R4 advertises only one path to the 198.1.1.1/32 destination and advertises all 3 paths to the 199.1.1.1/32 destination. Because of the prefix policy that is applied to router R4, router R4 does not advertise multiple paths to the 198.1.1.1/32 destination. Router R4 advertises only one path to the 198.1.1.1/32 destination, even though it receives multiple paths to this destination. Okay. So they said the reason for that is because of the custom prefix list that was applied. So let's take a look at that. Okay, so yep, we can see we've got a prefix list that allows this exact route through this route filter. Now, of course, this is perhaps the simplest way to filter out routes. On the exam, it'll probably get a lot more complicated. But we've got this then accept, and then we've got an implicit deny as well. So that's why that other one isn't being accepted, even though we did not write a deny statement for it. We only had to write an accept because there's an implicit deny. Verifying that router 8 is receiving multiple paths. Purpose: make sure that router 8 receives multiple paths to 199.1.1.1/32. Destination through router R4. Make sure that router R8 receives only one path to the 198.1.1.1/32 destination through router R4. Action: show route receive protocol BGP 10.0.0.40. Okay, so let's perform that action on router 8. All right. Yep, everything looks good. Checking the path ID. Purpose: on the downstream devices, router R4 and router R8, verify that a path ID uniquely identifies the path. Look for the add path ID string. Okay, so let's look for that string, the add path ID string on router 4 and on router 8. Okay, so I'm just going to go through, pick it out like a needle in a haystack. I think that'll help me kind of understand where it is. So, okay, so we've got an add path ID of 3, and that belongs to the INET 0 table entry for that route. And this belongs to the BGP route that was learned and added to INET.0. It's got a path ID of 3. Now it also learned another one, and it actually learned 2 more. And that makes sense because we've got those multiple next hops. So we're going to be learning a route for each next hop, and then we're going to be choosing the best route. So we got a path ID of 2 for the second one we've got. And then we've got a path ID of 1 for the last one that we've got. So the path ID very clearly seems to have some sort of say over which one is selected. Let's take a look at all of the differences between these two. I'm just curious enough to do that. And I've got plenty of time, maybe 15 minutes. Got a 1 o'clock meeting today, so I don't want to go too long. Yeah, I'm just garbage, man. I need to I need to get my health under control. Okay, so we're good to go. Oops, so it looks like there's extra lines in this one here. So that'll be interesting to see what the differences are. So let's put this over here. Yep, and now do a compare. There we go. There we go. So yeah, we can see we've got a lot of differences. So here's the missing line from the other one. So this has a cluster list and originator ID. The other one does not. Another difference is the address in the next hop count, reference count. More differences here. We've got the protocol next hop, of course, is going to be different. State is different. Yep, and this doesn't have the not best state. And it's inactive because it's not the best in its group due to the router ID. And this is inactive because of the AS path. So let's take a look at the okay, so here's the metric and just the age is different. So for the most part, those are the same. Aha, so here's the AS path. So let's see. So this one, the AS path was 2.22i. So let's take a look at the AS path from the one that is preferred. Okay, there. Oh, I see. Yep, so here is 2i. So it's got a shorter AS path. So it's going to be preferred over the other one, which has a longer AS path, which we can see, yep, right here. So we should have a inactive reason. Yep, inactive reason because it's got a shorter AS path. Now this one here, we can see the AS path is the same as this one here. So let's take a look at that. Yep, AS path, so 2i originator. Same thing here, 2i originator. But we've got an inactive reason for this. Now we won't have inactive reasons for this one because it is active. But the reason is because it's not the best in its group due to the router ID. So let's look at the router ID. Yep, here it is. So we've got 10.0.0.10. So let's take a look at the router ID here. Oops, so it looks like the router ID is also 10.0.0.10. So I'm kind of surprised by that. I don't know how the router ID would render this one inactive. Maybe it's the originator ID. So that could be it because we can see the originator ID is lower for the one that is active. So I think that's probably it because you know we're evaluating a route being sent, so we're using the attributes of that route, not the attributes of the router that is handling that route. And this is the attribute of the router handling the route. Oh, yeah, so it's going to be .10 for all of them. Yeah. That's not going to be different. That can't be used as a selection criteria because it's going to match, because that's just the ID of this router here. But the the originator ID. That's, I believe, what is used. In fact, let's take a look at this. Oops. So I guess that's not true, that it's the identifier for this. So yeah, it must be using the originator ID, but I don't understand that too much. Now I can look it up because I believe I do have treasure trove still on here, so I can run it again, and there should be something popping up for BGP. Let's finish this first. So there's one more, add path. So that is different as well. So let's clear all active compares. Go back to the verification steps here. So yep, we found the add path ID. Okay, now let's do that verification step on router 8. But before we do that, let's run the treasure trove. So we got it. So let's run that. Oh, I'm going to need to configure the OP scripting capability. Edit system scripts, set language Python, set OP file, treasure trove, .py, commit and quit. So I had discussed in a previous video the value of treasure trove, because one thing I did not realize is you can just do help topic, and then you can do or you can do a help apropos dot pipe match the help topic, and now you essentially get the same thing you get with treasure trove. You get all of you get back a help topic documentation, and you can go through this and you can determine, oh, is this going to be useful or not? But the problem with this is it turned out to be something like 3,000 entries, and I don't know which entry is going to be valuable, which entry is not going to be valuable. Yes, I can do a Control F and just try a bunch of them, but the thing is, if I run the treasure trove, then I filter it down to only documentation that contains the word example. So I guarantee that I have documentation that either is an example of something or shows me examples, but I really or shows me related documentation. So there's a flaw with that, of course. Let's see here. So set CLI screen length 0. Okay, treasure trove. So that filtering can be useful because I get rid of all of the documentation that's potentially not super useful, but unfortunately it is not. Unfortunately, I have been lately really questioning the value of using the treasure trove script versus just getting those 3,000 commands out here and then just searching through them. There's definitely a trade-off in filtering it down to what potentially would be more useful documentation. And not only that, there's really no guarantee that just because it has the string EXAMPLE : in it, that it is a high quality piece of documentation. There could be, their language is very inconsistent in these documentations, so there could be a really nice write-up where they don't have that particular string included in the write-up. All right, but let's, yep, now that that's going, let's go to router 8. Oh, I'm feeling a lot better now. Still not feeling good though, that's for sure. All right, so let's run the next verification command. Okay, and we're checking for the path ID. Yep, add path ID. Let's check for that. So it looks similar as the other one. We've got 3 routes that were learned, and we've got 1 that is selected. Let's look at the reasons the other 2 weren't selected. So this one is inactive because it's not the best in its group by merit of the router ID. So again, the router ID matches amongst all the routes, so that looks like it's a little bit of a misnomer, and they're probably going by the originator ID because we can see the originator ID is lower in the one that is selected, aside from the one that was not. And this one does have the lowest originator ID, but we can see that it is inactive for a different reason besides that, is because of the AS path. And we can see, sure enough, the AS path is an extra, has an extra AS in it. And not only that, it has an AS in there twice. So the BGP looping mechanism will shut that down. So these have the same path. They don't have a duplicate in the path, so they're both valid. But this one has a originator ID with a lower overall value. Okay, so let's look for the add path. So the last one that wasn't selected is add path 1. Then we got 2, and then we got 3. Okay, so we verified everything. So yeah, that's all the verifications. Yeah, I think this was a pretty valuable exercise. I got through, I got more comfortable with this show route detail. One thing I really liked is I've got this output. Of course, it's not going to be in the active path, but in any path that is inactive, I've got this output inactive reason, and it'll tell me the reason it's not active, and I can go from there. Really, really useful command. Of course, we went through the absolute key, most important commands: show route receive, as well as show route advertising. Yeah, BGP, and then you got to specify the neighbor. Those are going to be absolutely essential commands to pass this test. Aside from those commands, we also learned another command, and that is show BGP neighbor. We learned some details in there. We learned what the neighbor was capable of doing, whether it's capable of simply receiving routes, whether it's capable of simply sending routes, or whether it's capable of both sending and receiving routes. So let's do that. Show BGP neighbor. Okay, and we were able to figure this out by doing a little bit of mental gymnastics. So once we see this table here, we know that the one before that is where this is, and we know that NLRIs, for which peer can send multiple paths, it does have that capability for iNet unicast. So this will be important for L3 VPNs and stuff as well, because we'll need to, if there's a question where it's not learning a route, we can just check this and see, oops, it's not enabled for VLANs. And we got to do a little bit of mental gymnastics because we're talking about this peer here. So the peer can send, so we know that R8 can receive. So if we're checking whether or not R8 can receive from a peer, we've got to check whether or not that peer can send. And vice versa, if we're checking whether or not R8 can send to a peer, we've got to check whether or not a peer can receive. This one can't receive, so R8 can't send. But if we take a look at our configuration again, that's okay because we don't have any routing policy that sends routes, so it's really not important. On router 4, we do have that policy. Yep, and we can see right here with the route filter, and we're going to accept. So in our BGP group, we're going to have an export statement. So we don't have an export statement because we're not going to be simply exporting it. We're going to be family unicast add path. We're going to be adding it as another path it can use. Yep, so it's got to be family inet unicast add path receive. So let's take a look at that show BGP neighbors command. Yep, so its neighbor can receive, so we can send to this neighbor here, router 8, and its neighbor can send, so we can receive from this neighbor here, router 1. So lots of pretty complicated things going on. This is serving as a route reflector, and it's hooked up to router 8, and it's allowing extra paths through these extra statements. Yeah, pretty complicated stuff, but I found this using the treasure trove, so I'm hoping it won't be impossible for me to do the same on the test. And if they kind of go there and get really complicated in detail, I can just use the documentation. All right, so I got to end it there because I got a meeting at 1. So thanks for watching, and I'll see you in the next one.